Hello, everyone. Welcome to the last week of school before Thanksgiving break. We've almost made it. We have 4 days of school left, and then we're on Thanksgiving break. And before you know it, the year will be over. Okay, so remember that on Wednesday, we are taking the Unit 4 test. So today's our last lesson in Unit 4. Tomorrow, we're going to review for the test. Then we'll take our test on Wednesday. So today, what we're going to talk about is something called the line of best fit. And you may have talked about this before. So we're going to look at some notes that we've already put into our journal. So we're going to go to our journals and fill those out. So you will need your Algebra 1 journal open today. Then we're going to practice that just a little bit. So let's talk about what does it mean to have a line of best fit? What are we talking about here? Okay, well, let's say that we have a graph and it's got some points that have been graphed on it. Okay, here we go. So this is some data that's been collected that does something. So let's say I want to model the trend in this data with an equation of a line. It looks maybe something like this. So if we were to draw our line and say, if we're going to go straight through the center of that data and try to fit the data as close as we can to this line, well, this is what we mean by line of best fit. What is the equation of the blue line that would model my data the best? And so we also talk about something called correlation when we're talking about line of best fit. How closely is your data fitting to that line? Is it really, really close like this one? Like most of my data points are kind of hugging pretty close to that line. If so, we call that correlation. What is the correlation? And we can talk about correlation be positive or negative. So if you're looking at the blue line right now, you can look at it and go, well, I can see from left to right that line is going up. It looks like my data points are headed up. That's positive correlation, right? The blue line would have a positive slope. So this is what we call strong positive correlation because the points are positive, first of all. They're headed up in a positive trend, and they also are hugging pretty close to my line. So when I graphed those points before the blue line was there, I could tell they are trying to make a line pretty closely. So we call this strong positive correlation. There's actually a factor that we use to measure how closely points are correlated to a line. This is also association. Remember, correlation and association are the same thing. Is there an association? So this might be ice cream sales and temperatures going up outside. So as the temperatures go up, your ice cream sales are also going up. That's positive correlation. That's what this data could be modeling, something like that, a situation. But it's something called R. And so I'm going to show you how to find this and how to find the equation of the blue line. And this is all going to be done using your TI calculator. So let's say maybe we have another graph with some points on it. Now you see how these are kind of spread out a little more? They're not really like as close together as they were in the first one. However, I could still find the equation of a line kind of that fits the data best. See how it's not really like covering most of the points, but it's going kind of through the center of our data. So this is kind of what we call weak positive correlation because the points are still going up. I can see they're still in a positive trend here. And I could put a line through them, but it doesn't really model it like perfectly. So there's still some correlation, but it's weak. It's not near as good as our other slide was, right? With the points really close to the line. So sometimes we have strong, sometimes we have weak correlation, and sometimes we could call it moderate. It's kind of in between the two. So here's another example. Let's say we had points that were going down this way. Now, do you see how these points really are trying to make a line? Like I can clearly look and go, those points are trying to make a line. And I could draw that line, the line of best fit through the center of the data. So this is what we call very strong negative correlation because the slope of my blue line now would be negative. So this is negative correlation. And it's pretty strong because the points are, clearly can see they're forming a line. Now, however, here I can see my data still trending down. It still looks negative if I was to draw a blue line through the center of the data. That would be the line of best fit. But they're not near as close as they were in the last one. They're kind of spread out more. So this is what we would call weak negative correlation. Now, we can have strong and weak correlation, and then sometimes we have our data points and they get plotted on our graph, and boom, they are all over the place. This is what we would call no correlation here. If I was to draw a line through the center of that data, there's so many points far away from my line, I can't say that there's correlation here. So this would be no correlation. So let's take a look for today. We're going to start off. We've got an assignment on the modules page that we'll come back to in a minute. So here's my modules page. Down here, we're going to do a little bit of practice, but first let's go ahead and head over to our journal. So if you need to, pause the video now, find your Algebra 1 journal and open it up. Here is your table of contents. This is the last entry for Unit 4. Unit 4, Lesson 8, line of best fit, and it should be linked to slide 20 in your journal. So I'm going to zoom in here. So you will need your TI calculator for this. Now on this page here, the very first page, this is all steps. That's all this is. This is every single step you need to take to get your calculator. First of all, to draw the line of best fit, and then to tell you that what we call the correlation coefficient. How strongly is your data trying to form a line? So I have my calculator here, and you may want to bring up your journal or your calculator and go through these steps with me. Let me see if I can make this a little smaller so we can see our steps here in our window. Okay. It may not. There it goes. There's my screen down. So the first thing you need to do is select mode. So on your calculator, you're going to want to find the mode button. It's right here. Notice when I press it, it turns it red so you can see where to find it. Then you're going to go all the way down until you get to Stat Diagnostics. Now, you're going to have to arrow down quite a bit. And don't stop, because look, you can keep going down. And now I see here I am on Stat Diagnostics. I'm going to want to arrow over and hit Enter to turn that on. If that's not on, it won't tell you the correlation coefficient. So once you've hit enter and turn that on, now you can go back and you could hit any button actually. You could hit second, quit, and it's going to take you back to your calculating screen. That feature is going to stay on. So then the next thing you're going to want to hit is Stat Edit. So you want to hit Stat and then enter for edit. Okay, now look where we are. List 1, list 2, list 3. We have seen this before. We have done this before. You're right, we have. This is not new. The only new step was hitting mode and turning Stat Diagnostics on. We have already done everything else we're going to do. Now we're just going to get more information when we do Stat Edit. So if you're confused and you don't know what I'm talking about with Stat Edit, this was when we went back and we did linear regression earlier in Unit 3. This is how we write the equation of lines using the calculator. So all of these steps here are exactly the same, except now, notice, after we go over to calculate and arrow down and hit select option 4, hit calculate, it's still going to give us A, the slope, B, our y-intercept, but this time we're going to get a value for R, the correlation coefficient. So the best thing for us to do is look at some examples here. So here's one example. Here's a table of values that has the age of a car and the value in thousands of the car. So notice when our car is 1 year old, it's worth $24,000. But when it gets down here to be 8 years old, it's only worth $7,000. So this is what happens with cars, right? You buy them brand new and they cost a lot. And they say as soon as you drive them off a lot, they're worth less than when you just paid for them 30 minutes ago. So cars depreciate in value. The value goes down over time because they get old and worn out. And then they go and buy another one. So we're going to work through this example. The information up here we're going to use in a minute because it's going to help us identify some of this other information. And this all has to do with R, what we're getting for the value of R, which is a new value that we're going to get. That's our correlation coefficient. So if we're going to do this, then we come over here. So I'm going to hit clear. So remember, I'm going to actually quit out of the screen. So all we have done is we have gone to stat. No, actually, we went to mode, first. And then we arrowed down until we got to Stat Diagnostics. And we made sure it was on. Now, when you go to take STAR test or something at the end of the year, this is going to be off because your calculator is going to be reset. So or when you go to take a test or something, It's important that you remember to turn this on first. Otherwise, you won't ever see R. It's not going to tell you the value. So now we can hit Stat, and we hit Enter for Edit. And we put our X values always in list 1. Now, when they give you a table that's a vertical table like this, X is always this side over here. X is the age of the car. So I'm going to enter my values here. 2 and 3 and 4 and 5 and 6 and 7 and 8. Okay, so there's my values, my X values. Now on the other side, I'm going to enter my Y values. Now notice these are in thousands, so it's 24,000, 21,000, 19,000, 18,000, 15, 12, 8, and 7,000. I have my values in. Now I go back to Stat, and I go over to Calculate, and I want to choose option 4. So I'm just going to hit the 4 on my calculator. And then I'm going to go down to Calculate, and I'm going to hit Enter. Now, I know your calculator looks a little different on your Chromebook, and if you're not sure how to pull up the TI calculator on your Chromebook, you need to message me immediately. I have sent out several videos explaining how to do this, but you need this TI calculator. The TI calculator is the only one that's going to do this for you. None of your other calculators are. You hit Enter. Okay, boom. So now we have been given, usually we just get A and B and we're done. But because we turned on the stat diagnostics at the very beginning, now we're getting values for R squared and for R. So all we're really interested in is A, B, and R. We don't really care about R squared. That's when you're doing statistics, that's important. We don't care about that. So the first question it's asking me is, what is the equation for the best fit line? Now you are always going to get crazy ridiculous decimals when you do this. I want you to round your answers. We're not going to try to convert these to fractions. When you're doing a line of best fit, remember, it's an approximation. It's the best fit. It's not going to be a perfect value every time. We're going to end up having to round. So I'm seeing that I have a negative 2.47. I'm going to round that to negative 2.5. If you want to do 2 decimal places, that's fine. So remember, when I write my equation, I'm going to say y equals, I'm going to put my A value first because that's my slope, then the X, then plus my B value. So I'm going to say over here, it is y equals negative 2.5x plus, now I need my B value, so let me pull my calculator back up. 26.64, and again, I'm going to round that to 26.6. So there it is right there. There's the equation. That's not new. We've been doing this. We have been finding equations of lines, typing in A and B. What is the type of correlation? So this question comes up. So what they want to know is, and you can look up here, the type of correlation is either positive, negative, or no. So we're looking at here, and we have an R. This all comes from R. Your type of correlation comes from R. So my R value is negative 0.99. Because my R value is negative, and it's really, really, really close to being 1. 0.99 is really close to being 1. This is going to be negative correlation. It's definitely negative correlation. What is the correlation coefficient? Well, remember it was negative 0.99. And again, you're going to round this because this is a really long decimal. We're going to put 99 and just 14. We're going to go there and then we're going to stop. Round it there. Chop it off at 4 decimal places. What is the strength? So that's where you come over here and you look at this chart and it will tell you the strength. Well, since it's negative 0.99, and notice it's telling you to look at the absolute value of R. I don't know if you remember absolute value, but it's telling you to look at R without the positive and the negative sign. I don't care what the sign is. The sign on R, if it's a negative number, then it's negative correlation. If it's a positive value for R, it's positive correlation. Simple enough, right? So this is telling you, and I misspelled negative, guys. I'm just now seeing that. I'm having trouble spelling when I type. I'm typing everything backwards. So this is telling us that our trend, our data is going down. Our line has a negative slope, and it does. Look over here. It's negative 2.5. So my line is from left to right is going down. It's descending. And this is telling me that my value, my correlation is negative. Those agree. They should. Now, what they want me to look at is without the positive or negative sign, just the 0.99. If it's about from 0 to 0.3, it's very weak. Like weak correlation, like the data are not very close to that line of best fit like we saw earlier. If it's between 0.3 and 0.67, it's moderate. But if it's higher than about 0.67, it's strong. And if you ever get a correlation coefficient of 1, that data is like ... perfectly on top of your line. So this one is very strong. It's not perfect, but it is definitely strong. So you need to be able to identify if it's strong, if it's weak. That's really, really important. So you can think 0.6 or higher, 0.7, that's pretty strong. And you can think 0.3 and lower, that's going to be pretty weak. The data is just not close to our line. Okay, so now we're going to use this to make a prediction. So we have this equation that predicts, like if we were to plug in 1 here for x, we did negative 2.5 plus 26.6, we're going to get about 24,000. That's what this equation is helping us find. So if we were to plug in each one of these x values, we're going to get about this value in thousands here. So we want to use that to predict the value of the car when it's 10 years old, in 10 years. So if the car at 8 years is only worth $7,000, we would expect when it's 10 years old to be worth even less than that. So let's see, we're going to use our equation to do that because I know that this is my equation. They're giving me a value for the car, negative 2.5 times, well, now I'm going to say 10 years. My x is going to be 10 years. They only gave me up to 8 in the table. That's why this equation is important, because it helps me predict beyond the values that I've been given. So if I was to plug in that 10 years right here for x, and then I could add 26.6. Well, what are we going to get here? We can simplify this. That's going to equal, I'm going to do it in my calculator. Let me pull the calculator up over here. So let me hit clear so I can get off this screen. Negative 2.5 times, and I'm going to plug it in exactly like I'm seeing it, 10 plus 26.6. What do I get? I get 1.6. 1.6, not dollars. Remember, this is in thousands. So if you want, you can multiply this times 1,000, because we did get a decimal, and that'll give you your answer. About $1,600 is how much this car is going to be worth. So the value in 10 years is going to be about $1,600. So this is what we're doing. This is what we need to practice. We need to practice doing the stat edit like we have been with our table, getting our equation of our line. That's best for this one. We're going to have to round some decimals. And then I want you to be able to look and say, okay, is it positive, negative correlation? How strong is it? Is it weak, strong? And then we're going to use that equation that we found to predict a value. So that's it for your notes. Now, if you come back over here to Canvas, at the bottom of the modules page, here is your assignment for today. It's pretty short. If you click here, and it might tell me that I have to click this and open it. Let's see if it's going to load. Sometimes it doesn't load. Yes, your teacher needs to open the assessment first. Okay, so let me go over there and click on it real quick out of this mode, and then I can come back and it should let me open it. Okay, so now it's open. So you've got this worksheet. It literally has 4 problems on it. That's it. So what I want you to do is go through and do the exact same steps that we've been doing. Your diagnostics should already be on, so you don't have to turn that on again. You're just going to keep going back and starting at the stat edit steps. You're going to type in the values. You're going to write out the equation that you get, plugging in A and B in the right spots. You're going to figure out what's your correlation coefficient, and then you're going to decide, is it strong, moderate, or is it a weak correlation? And then you can also put if it's positive or if it's negative correlation, because that's important. That depends on R, the value of R. Or you could look at your slope and decide, is my slope positive? Is my slope negative? That will tell you. And then you're going to make a prediction. So you're going to be using that equation you found up here to figure out what the value of Y is going to be when you've been given a value for X. So you're going to be plugging in for X for every one of them, okay? So practice that. Get this submitted, so I'll take a grade on this. And then if you have any questions, let me know. We can schedule a video conference and we can work through some of them together if we need to.